Hey there, today we're looking at how to utilize linear graphs to solve real-world problems. This is another section where most of the practice problems will be on the computer. However, you will have problems similar to this on your test as well. So, as always, they give you a scenario on the computer for this. Now I'm going to page forward and see that we have a table just like we had a couple of sections ago. This quantity name, remember that this first column, the quantity name, I always skip down to the end of the problem. And it says to write an expression, define a variable for, in this case, the time. That thing that I'm defining the variable for is always the thing that goes in this first column heading. And then I go back and it says to use the variable to write a rule for the number of square miles of rainforest that is being cut down. That's a long title. If it's on the computer in particular, though, as much as you can, write that whole thing down. So the number of square miles, so number of, and you wouldn't use the number sign on the computer, of square miles of rainforest cut down. Now the units for time, units, so this is where some people want to put the variable. This is not the variable. Units are for time, minutes, hours, years, etc. So now I go back up to the problem. It says cut at a rate of 9 square miles per hour. So my units for time, hours. And if it's talking about the number of square miles, then my units for this is square miles, not just miles, square miles. Now, going back to question 1, in 2 hours, how much rainforest gets cut? So the number of hours is 2. As for how much rainforest get cut, it tells me it's a rate of 9 square miles per hour. So I'm going to take 9 times 2 and get 18 square miles. Question 2 says, how much rainforest gets cut in 2 days? Well, I want to convert this to hours. So 2 days times 24 hours per day is 48 hours. So I'm going to go back and it's 48 hours. And then, to the number of square miles of the forest cut down in that period of time, well, 48 hours times 9 square miles per hour. So 48 times 9, and if it was in the computer, I could just put 48 times 9 in here and it'll calculate for me. On the paper, of course, I need to do that myself. And 48 times 9 is 432. And then I go back and it says, how much rainforest is cut down in 1 week? Well, now I have to figure out how many hours in 1 week. Well, there are 24 hours per day, 7 days per week. So if I take 24 times 7, I get 168. So that's going to be 168 hours. To figure out how many square miles that's going to be, oops, and I went in the wrong direction, I'm going to take my 168 and multiply by 9. So 168 times 9. Again, if I were on the computer, I could just type this into the cell and it would calculate it for me. If it's on a paper, I need to calculate it myself. So 1,512 square miles. Now at this point, it wants me to go and graph the number of square miles as a function of time and use the graph to answer the question. So if it's the number of square miles as a function of time, and that time is measured in hours, is my label on this axis, and this axis is going to be square miles. I could type out the entire description here, but if I just put the units, like I could have just put hours here and square miles here, and it'd take it. Now, the next thing it's going to ask me to do is I have to tell it what my minimum and maximum y values are and my minimum and maximum x values, and that's going to be based on what's happening in the table. Well, the x-axis, the one that goes across, is these numbers, and I can see already that I have to get up to at least 168. Now, I am going to go take a peek at question 4. How many hours are required to cut down 900 square miles? So I know that this answer is 900. I need to find the hours. What this also tells me, though, is 900 is less than 1512. So if I can get up to 168 on that axis, then I'm going to have plenty of room to graph what I need to. So I'm going to start at 0, and I need to go up to at least 168. I'm probably going to go up to 180. Now, I don't have the luxury of making these boxes bigger or smaller like I do on the computer, and I'll show you that in a little bit, but I can set my scale. So in this case, 20, 40, 60, 81, 20, 40, 60, 80, I could, my x interval says, what's my scale? What do I need to go by? I'm going to go by 20s, so I'm going to put a 20 in there. And then on the computer, it'll do this labeling for me. Here on the paper, I need to do it for myself. So 20, 40, 60, 80, 100, and then keep going until I get to 180, because I have to graph as far as 168, and it's easier to go by, if I have large numbers like this, by maybe 10s or 20s, oops, 160, not 168, and 180. Now, my y-axis, I need to get all the way up to 1512. So that's going to be, I'm going to start at 0 again, but if I need to get all the way up to 1512, and I can't go by hundreds because this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, that'd be 1,000, and I wouldn't quite get to, I won't get to 1512. So I'm going to go, instead of by 100s, I'm going to go by 200s, and this will be 200, 400, 600, 800, 1,000, 1,200. It's easier to do on your paper. 1,400, 1,600. So I'm going to tell it to go from 0 to 1,600, and I want my y interval, my scale, to be going by 200s. Now on your graph, you don't have boxes that are fixed at this size, so I'll show you what that looks like in just a little bit. Now I'm going to plot the points that I have. The time on the x-axis is 2, and the number of square miles is 18. So if this time is 20, 10 would be halfway, 5 would be half of that, 2 is going to be less than half of that, and then I lost track of, and 18 is, so this is going to be actually really close to the origin, this point, because 18 compared to 200 is very small. And then 48 and 432. So if this is 40, 50 is halfway between, so 48 is a little bit less than half. 432, well, halfway would be 500. Half of that would be 450, so it's going to be a little bit less. This is going to be roughly there. And the next one, 168 and 1512. So 168 would be not quite to 170. And 1512 is going to be more than halfway between 1400 and 1600. So again, roughly there. Now, once you get those 3 points plotted on the computer, you're going to go up and click this thing that says to draw your line. Obviously, in real life, you can't do that. So in real life, you're going to grab a ruler, grab a straight edge, and set it down. And if you did this correctly, oops, and my goodness, this is being difficult. I'm just going to move this one out of the way. If you do this correctly and everything's lined up, your line should go right through those 3 points you just graphed. And I'm going to make those points just a little bit bigger so you can see where they are. There's one of my points, there's the other point, and here's the third point. And if I can get that, it's a little hard to do with this on the computer. I'm going to extend my line through. There we go. So once you do that, then on the computer, it's going to say, hey, now use your graph, and if the number of square miles is 900, how much time would that take? So what I would do on paper is I would set my ruler down, and I don't have that here, and I'd say 900 is halfway between 800 and 1,000, and I would kind of do this dashed line across from 900, and I see, wow, that actually falls directly on a time of 100. So my answer then I go and put in is 100. Now I need to write my expression. The first thing here is the variable I'm going to use for time. Well, since it's in hours, I'm going to use h. Again, if it was years, I can't use y. I'd have to use maybe t for time. And what I did with the number in the first column to get the number in the second column every time was I multiplied it by 9. So my expression is 9h. Now let's go see what that looks like on the computer and how it's going to make you do things on here. So I'm going to go to the example because this was from the example. Again, the quantity name, I always go down to define a variable for. The quantity name is the time. And then they're actually highlighting it for me because it's the example. Write a rule for the number, and notice I'm typing of all of this in, of square miles of rainforest that is being cut down. And I'm going to go back and just scan through that to make sure I didn't do a typo. It's really horrible to have to do more problems because you do typos. My unit I chose, in this case not chose, they said hours. The number of square miles, well, you measure square miles in square miles. In 2 hours, how many have been cut down? Well, we said to take 9 times 2 to get that answer. I can either type 18 in here or show it 9 times 2, and it'll calculate it for me. 2 days, I could say, well, it's 2 days, 24 hours per day, and it'll do that calculation of 48 for me. And then that times 9, because it's 9 per hour. 1 week, well, 24 hours a day times 7 days is 168 hours. And then I'm going to take that 168 and multiply it by 9 because it's 9 square miles per hour. At this point, they want me to graph these points. So this box, they're asking me what's going to be on my y-axis, and that's my square miles. On my x-axis is my hours. Now, we said when we were looking at this on the computer or on the paper to start from 0, I need to get to 1512, so I'm going to go to 1600. Here it's saying, hey, I can't do this on this graph. I can't go from 0 to 1600 by ones. So I'm going to choose to go from 0 to 1600 by hundreds. I had to go by 200s on my paper just because I was limited to the number of squares I had. Here I can go by hundreds, and it'll just readjust the size of my squares. I need to go from 0 to 168 down here, so I'm going to go from 0 to 180. Now, although it does actually fill in boxes, I can't tell what anything is. So if I'm going to go from 0 to 180, I'm going to maybe go by tens. So I'm going to set my x interval at 10. That gives me nice size boxes to be able to find my points. Now, I'm going to graph point 1. It says I should go to 2 and 18. So 2 is less than 10 about here. 18 is way low. So this point's going to be pretty close to the origin. As long as I get it close enough, it'll adjust it for me, but I have to get it close enough. Graphing point 2, 48 is going to almost be to 50. And I'm going to go up to 432. Again, that's, if you see on the left side, it's less than 450, so it's less than halfway between 400 and 500. My third one, 168 is not quite to 170, and I'm going to go all the way up to 1512, so a little bit less than 1500. At this point, once I get those three, I'm going to hit draw line, and it does it for me. Now, it wants 900 square miles, and it wants me to graph the point for that. So 900 square miles is here. I'm going to go over to my line and plot my point. And as I do that, I'm going to look down where that dashed line goes down to the x-axis, and it's at 100. So my answer here is 100. Now I'm using h for my variable. I could use t because it's time. I could use x every time if I really want to. And what I did every time to get the number in the second column is I took that and I multiplied it by 9, so 9 times my variable. Once I'm done there, I've done everything on this, and I hit done. That's it. Thank you.